Well, hello there. Welcome to Lesson 6.1 on square roots. And our learning targets for this chapter or this section are going to be number 1, understanding what a perfect square is. The second thing we want to be able to do is understand what square roots are. And the third thing we want to do is we want to create a list of perfect squares and square roots from 1 through 25. So let's go ahead and get started on that, shall we? Now, to understand what a perfect square is, we just need to look at a square. So if I have on example number 1 right here, and I want to know what the area of this square is, well, how do you find the area of a square? Well, yeah, a square is just a rectangle. And a rectangle, you find the area by length times width, or base times height. So we know squares have all the same length on all the sides. So this side right here is given as 12. So then we can assume one of the other sides are 12, the length, the width, or the height. And 12 times 12 is 144. So the area of this is 144 inches squared. So 144 is a perfect square number. Okay, so how would we find the area of number 2 when it says this side of the square is 5? Well, yeah, we would know this side of the square is 5, so the area is 5 times 5, which is 25. So we know that 25 inches squared is a perfect square number. So let's see if you can do number 3 really quick. So what is the area of this square? Well, yeah, you guessed it, it's 49, because 7 times 7 is 49. And since we're having units here, we'll say inches squared. So 49 is a perfect square number. Now, let's reverse the process. On this example number 1 right here, they say that the area is 16 inches squared, and they want to know how long one of the sides are. Well, how would we do that? So we want to figure out a side length, and we know that both of these sides are going to be the same length because they're a square. So what number times itself equals 16? Well, if you think about it, 4 times 4 is 16. So we know the side has to be 4. Let's try this one right here. If you know the area of this square is 49, what is the side length going to have to be right here? I'll put a little number symbol here. And that same number right here, what number is that going to have to be in order to get 49? What number times itself is 49? Well, yeah, that is 7. And so what we're doing here is we're doing something called a square root. A square root takes an area and finds the side length. So if we know the area of this one is 1, what number times itself equals 1? Yeah, it's just 1. So 1 times 1 is 1. So the square root of 1 is also 1. That's pretty interesting. Okay, so on this one right here, number 4, that's kind of an interesting problem. It says the area of a square is 36 inches. What is its perimeter? Well, first of all, before we can find the perimeter of the square, we have to find the square root of 36 to find the side length. So how would we do that? Well, what number times itself equals 36? Well, that's 6, because 6 times 6 is 36. Now, this problem's a little more advanced because it wants us to find the perimeter. And how do you find the perimeter? You just add up all the sides together. Well, we know 2 of the sides, 6 and 6, and since it's a square, we know the other ones have to be 6 also. And we're just going to add them up, because perimeter just means add all the sides up. So 6 plus 6 plus 6 plus 6, or you can think of it as 6 times 4 is 24. So the perimeter would be 24. And since we're dealing in inches, we should probably put inches here. Looks like we're dealing in inches all of these, so these would be inches, these would be inches, And these would be, it's always good to remember our units, right? Great, and we're done. So now what I want you to do in your notes is I want you to write down definitions and symbols, and underneath that I want you to write the word perfect square, and I want you to leave some space off to the side to write some things and write some examples. And underneath that I want you to write square root and leave some space off to the side because we're going to add some things to that. So go ahead and do that right now. Write definitions and symbols, perfect square with some space to write off to the side, and square root. Now, the first thing we're going to do is we're going to look at a perfect square. So thinking back at that last examples, those examples where we actually had to find the area of the square, what is a perfect square? Well, let me move this box away and we can say what it is. A perfect square is the answer to a multiplication problem where a number has been multiplied by itself 2 times. Let me say that one more time. The answer to a multiplication problem where a number has been multiplied by itself 2 times. Now, let's look at an example. So, the example that I came up with is 81, the number 81. 81 is a perfect square since 9 times 9 is 81. A number multiplied by itself equals 81. 9 times 9 equals 81. Now, let's look at an example that's not a perfect square. Well, I said 10 is not a perfect square because, or since, and I have a bunch of question marks here, so no number times itself equals 10. Well, you could say, well, 5 plus 5 is equal to 10, but we're not talking about plus. We want multiplication, so that doesn't work. 2 times 5 equals 10, but that's not the number multiplied by itself. 10 times 10 is 100. So there's no way to get 10 by taking a number and multiplying it by itself. So 10 is not a perfect square. Now, let's look at what a square root is. The number that was multiplied to make a perfect square. So it's kind of the opposite. A square root is the opposite, the number that was multiplied to make a perfect square. So go ahead and write that down so you have a good definition of what a square root is. The number that was multiplied to make a perfect square. So if I had, let's say, let me think of a perfect square number we haven't used yet so far. Let's say I think of the number, I don't know, how about 16? I don't know if we've used 16. Maybe we have, maybe we haven't. What number times itself equals 16? Well, 8 times 2 equals 16, but that number is 8 times 2. 8 and 2 are not the same number. But if we look at this, 4 times 4 equals 16. 4 times 4 equals 16. So we can say the square root of 16 equals 4. The square root of 16 equals 4. And we actually have a nice little symbol that will replace this whole kind of longer statement right here. Another way to say it, let me just do a little arrow off to the side to show you what that symbol is. It looks like a division sign with a check mark on the front. So a division sign with a check mark. We'll put 16 inside the little division sign with a check mark, and we know that that answer, the square root, this means square root right here, equals 4. The square root of 16 equals 4. So here's another way to do it with a symbol. This is a symbol if you want to write that down. That's the symbol of a square root. And pretty neat. We're done. Now what I want you to do, and I want you to take some time and make this look neat, I want you to open up to an entire piece of paper. So just turn your notebook, and I want you to find an entire piece of paper. And most likely you're working on lined paper if you're working on a spiral. So you can use the lines to help you kind of make nice straight horizontal lines. And then I want you to take, at the top of your piece of paper, I want you to write perfect square and square root table. And I want you to make 3 columns. I want you to write number, and notice you don't have to make it very big. And then I want you to make a long column. Now notice you can't see my whole screen. I go all the way down to 25. So I want you to go all the way down to 25. So I want you to start at 1, and I want you to count all the way down to 25. Hopefully you have enough lines on your paper. If not, you might have to go to the next page. In the next column, and notice it's a little fatter, this column, I want you to write perfect square. And then in this column, I want you to write square root. And what we're going to do is we're going to build this table. So I'm going to pause the video right now, and I want you to pause the video, and I want you to go ahead and make this table 1 to 25, number, perfect square, and square root. And at the top, you're going to label this as perfect square and square root table. Okay? So I'm going to pause the video and let you go ahead and make the table. Now, once you've made this table, and if you please raise your hand right now on the video on Teams and let your teacher know if you need more time. But once you've made this, your teacher will begin to start to fill this table in for you. And I bet you can start to see it. So remember what a perfect square is. You're taking the actual number and you're multiplying it by itself to get the perfect square. So if we do that, I'll do perfect squares in purple. So we're taking 1, and then we multiply it by itself because we're going to create a perfect square, and we get 1 times 1. Well, that's easy. That's just 1, right? Okay. And then we can do this with 2. So we have 2 times 2. So we know 2 times 2 equals 4. Okay? Now, we can also say 3 times 3. So 3 times 3. Now what's 3 times 3? 3 times 3 equals, I should put my equal sign there. 3 times 3 equals 9. And 4 times 4 equals 16. So we've built a few perfect squares here. Let's go across the column to square root, and let's see how we'd fill those in. I'm going to fill those in blue. So if I'm going to look at the perfect square right here, which is 1, and so I'm going to take the square root of that. So remember our square root symbol, it's the check mark with the division check mark, and I'm going to put that inside. What's the square root of 1? Well, what number times itself is 1? Well, that's just 1. And then I'm going to take this perfect square, 4, and I'm going to take the square root of that. Well, what number times itself equals 4? Well, 2 times 2 equals 4. Okay, let's try the next one. We want to take the perfect square, so we want to take the square root of 9. What is the square root of 9? The square root of 9, what number times itself equals 9? Well, 3 times 3 equals 9. So the square root of 9 is 3. And likewise, 16, the square root of 16, square root of 16 is equal to 4, because 4 times 4 equals 16. So what I want you to do is, remember we went all the way down to 25. Some of these are going to get pretty big, so if you get confused and you don't know the answer, just wait a while and we'll fill them in together as a class. So I want you to go all the way down to 25, so the next one would be 5 times 5, 6 times 6, 7 times 7, 8 times 8. And then over here, I want you to take the square root of those answers. So 5 times 5 is 25, so here you take the square root of 25 and get that. Okay? So that's what I want you to do to build this table real quick, and I'll come back and I'll have this table filled in and you can check your answer. Alright? So I'm going to have the teacher pause the video, give you a second, and then when he feels or she feels you're ready to go, we'll make sure our perfect square and square root table is filled in. Okay, so we left off at 5 times 5 is 25. Hopefully you have that. If not, go ahead and write it down right now. 6 times 6 is 36, so 36 is the perfect square. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196. 15 times 15 is 225. 16 times 16 is 256. 17 times 17 is 289. 18 times 18 is 324. 19 times 19 is 361. 20 times 20 is 400. 21 times 21 is 441. 22 times 22 is 484. 23 times 23 is 529. 24 times 24 is 576. And 25 times 25 is 625. So you have a pretty, I mean, we could keep going to 26 times 26, but we're going to stop there because that's a pretty extensive list of perfect square numbers. Now let's look at the square roots. And once you know your perfect squares, square roots are easy. So we already know the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. The square root of 81 is 9. The square root of 100 is 10. The square root of 11, square root of 121 is 11. The square root of 144 is 12. The square root of 169 is 13. The square root of 196 is 14. The square root of 225 is 15. The square root of 256 is 16. The square root of 289 is 17. The square root of 324 is 18. The square root of 361 is 19. The square root of 400 is 20. The square root of 441 is 21. The square root of 484 is 22. The square root of 529 is 23. The square root of 576 is 24. And the square root of 625, of course, is 25. So this is a really important list to have. Make sure you get this list and have it ready to go because we're going to be using this list a lot. So maybe fold the page in or put a little star on this page because it's a really important page to have when we start doing problems that involve square roots. Okay, now that we've learned some, let's use some of the things we've learned the last couple days and let's have you try these. So right now I have 3 problems here. The square root of 121, 24 to the second power. And I want you to evaluate or simplify this expression right here using your order of operations. See if you can do it really quick. We'll pause the video. Well, looking back at your chart that you made that I said was going to be very important, if you look at the square root of 121, well, what number times itself equaled 121? Well, yeah, that was just 11. And when you look 24 squared, which is 24 times 24, when we write it out longwise, what was the answer to 24 times 24? Well, the perfect square of 24 times 24 is 576. So that was our answer there, 576. Now, on this last one, we want to use our order of operations. So what do we want to do first? We want to do grouping first. So 6 minus 2. 6 minus 2 is 4. So I have 5 plus 8. Now what does it mean when there's no symbol in between a number and a parentheses? That's assumed multiplication. So we can replace this now. We know there's a multiplication dot. And 6 minus 2 is 4. So we're done with the parentheses. The next thing we want to do is exponents. Do we have any exponents? Nope, no exponents. Next thing we have is multiplication and division. Do we have multiplication and division? Yes, we do. 8 times 4, which is 32. So this problem is 5 plus 32. And what's the answer to 5 plus 32? Yep, that's just 37. And you're done. How did you do with these problems? Do you think you can understand it, or do you need some more help? Now what I want you to do in your notes is I want you to write this down. Simplifying square roots with fractions and decimal examples. So if you'll notice on your homework tonight, you'll have some that are a little more complicated. So let me show you how you can tackle problems like this, because they don't look exactly like what we have in the chart we made. But we can definitely use the chart to kind of make it work for us. So here we go. Let's take a look at number 1. Well, the first thing I see on number 1 is I have this plus or minus. And I'm not going to let that scare me. I'm just going to copy that plus or minus down in my answer. And we'll kind of talk about that later, but for right now, you just need to copy it down. There's no big deal with that. Just copy it down. It just means that you're going to have a positive answer and a negative answer in your solution. But you don't have to worry too much about that. Now, there's a rule of square roots that when you have a fraction, the first thing you want to see if you can divide. And I don't think 16 and 49, there's a number that divides both of those. I wish there was, but there's not. So the next thing I'm going to do is I have this rule that we have this big square root right here, and what I can do is I can break it up into little square roots. A little square root on top over a little square root on the bottom. So that's a nice rule of square roots, that you can always break it up into a big square root over the numerator and denominator can be broken up into a little square root in the numerator and a little square root in the denominator. And so we'll just put 16 up here. And then we'll put 49 right here. Now, don't forget your plus or minus, because that's just going to be part of your answer. We're not going to worry too much about that. So we have plus or minus. Now, what's the square root of 16? Hopefully you don't even need your chart for that. What number times itself is 16? Well, yeah, that's 4. And what number times itself is 49? Yeah, that's 7. So my answer to the question is plus or minus 4/7. Sorry, my handwriting's getting a little messy here with the tablet. So plus or minus 4/7. And that would be my answer. So your job is to go ahead and see if you can't do number 2 using the same way we did number 1. Well, the first thing I have to remember is I don't have a plus or minus right here. So that's okay. So I'm just going to leave it alone. Now, what is the square root of 289? Well, yeah, in my chart, that's 17. And what is the square root of 441? That's 21. So my answer is 17 over 21. And I'm done. Now, on this one right here, I notice there's a negative sign out in front. And I'm just going to copy it. Just like I copied the plus or minus, since there's a negative sign out in front, I'm just going to copy down the negative sign. Now, it's a little scary, though. There's a decimal, but don't let it scare you. What if this decimal here wasn't here? Let's pretend I'm going to put my pen over it. If this decimal wasn't here, it'd be 169. So what is the square root of 169? Well, yeah, that's 13. But it's 13 times 13 is 169. So 1.3 times 1.3 is 1.69. So all I had to do is just put the decimal here. And you can always check it if you're not sure. You can just leave the negative out in front, and you can take 1.3 and multiply it times 1.3. And you will find that when you multiply it and do your decimal multiplication, you get 1.69. So you can always check your answer if you want. Okay, so we're going to pause the video if you need it and go ahead and do number 4. Well, the first thing I'm going to do is I'm going to copy down the plus or minus. Then I'm going to say, well, if the decimal wasn't here, what would the square root of 529 be? Well, from my chart that I just made, that would be 23. So it's plus or minus the square root, plus or minus 23. And again, if you wanted, now it's 5.29, not 529, so we have to put the decimal right here. And if you want to check it, you can say 22.3 times 2.3 equals 5.29. And I'm done. Now, I have some more examples for you, and I want to call, these are examples that, let me give these a better, these examples are order of operations with square roots. And I want you to consider a square root as a grouping symbol. So remember in GEMDAS, G-E-M-D-A-S, M D A S. And remember, we had lots of different grouping symbols. We had parentheses and things like that. I want you to add square roots to your grouping. And so we want to do what's inside those square roots first before we do exponents, multiplication, divide, or add, or subtract. Well, let's take a look and see what that works. Well, before we start, one thing I want to notice is if you don't have a symbol between a number and a square root sign, it's assumed multiplication. So you just have to know that that's multiplication. We're not going to put it there for you. You have to know that. Okay? So the next thing we're going to do is we are going to do our grouping. And we just said that grouping is going to, square roots are part of our grouping. So what is the square root of 36? Well, yeah, the square root of 36. Well, the square root of 36 is 6. So now I'm going to rewrite this as 5 times 6 plus 7. I substituted a 6 in for the square root of 36. Now, I don't have any exponents. I do have multiplication and division. So I have 5 times 6. Well, what's 5 times 6? 5 times 6 is 30. 5 times 6 is 30. So 30 plus 7 is 37, and there's my answer. Okay, go ahead and try number 2 on your own and see if you can do it. Well, here we go. The square root of 81 is 9, so we have 4 plus, and remember this is multiplication, 3 times the square root of 81 is 9. Don't have any exponents, multiplication and division from left to right. Well, what's 3 times 9? That's 27. So we have 4 plus 27, and 4 plus 27 is 31. Now, the next one is a little tricky because if we try to break this up, we don't have, the square root of 18 is not a perfect square, and 2 is not a perfect square, so that could be a little scary. But let's simplify this 18 divided by 2. What is 18 divided by 2? Let's just do this math problem. Let's pretend that this was all by itself and there was not a square root sign around it. What would that be? What's 18 divided by 2? Well, that's 9. So we have 1/4 plus the square root of 9. Because 18 divided by 2 is 9. Well, what is, we're not done with square roots. We're not done with our grouping yet. We still need to actually take the square root. And what is the square root of 9? Well, that's 3. So this is going to be 1/4 plus 3. And what is 1/4 plus 3? Well, you could get a common denominator or everything, but if you want to write it as a mixed number, you can just say 3 and 1/4. And you're done. Okay, so use example 3 and see if you can't do number 4 now. Your teacher can pause the video and see if you got it, and if not, and then we'll work it through and see if you got it right. Okay, so the first thing you're going to do is you're going to take 75 and divide it by 3. Well, 75 divided by 3 is 25. So we have the square root of 25 plus 8. Remember, 75 divided by 3 is 25. That's where I got it from. Now, I haven't taken the square root yet. Now I actually have to take the square root. What is the square root of 25? Well, yeah, that's just 5. So now I have 5 plus 8. And what is 5 plus 8? I believe that is 13. And I'm done. Okay, hopefully this lesson was helpful and it prepares you to complete your homework assignment tonight, and your teacher will show you what that is. Good luck. See you later. Bye.